Okay, for what we have in number 8 as well as number 9, we have a 4-part question. And we have for the first portion, we're looking at the domain of each rational function. Okay, so for number 8, we have r of x is equal to 2x squared plus 2 all over x squared plus 6x plus 5. And for what we have in terms of the domain, okay, so again, we have a rational function, and we have that x squared plus 6x plus 5 cannot be equal to 0. And looking at what we have here, now x squared plus 6x plus 5 can be factored. And we have the quantity of x plus 5 times that of x plus 1 cannot be 0. And if x plus 5 cannot be 0, then we have that x cannot be equal to negative 5. And if x plus 1 cannot be 0, then we have that x cannot be equal to negative 1. So we have, in the case of the domain, and we have for part A, okay, so we have all real numbers except negative 5 and negative 1, and drawing upon the interval notation. So we will have those values of x less than negative 5. And then we have followed by those values of x greater than negative 5 and less than negative 1. And then we have for the rest, we have those values of x that will be greater than negative 1. And taking what we have now, okay, so we have with the rational function, if I were to take what I have and put into factored form, so I have 2 times the quantity of x squared plus 1, all over, once again, we have x plus 5, quantity times quantity of x plus 1. And if you notice, okay, neither x plus 5 nor x plus 1 will be a factor of the numerator. And so we have in the lead up to what we have in part B, okay, so it's going to follow that since x plus 5 and x plus 1 remain, okay, we're going to have our vertical asymptotes, okay, will both be negative 5 and negative 1. Okay, so we have vertical asymptotes, and we have x equal to negative 5, and also x equal to negative 1. Okay, and taking now for the other asymptotes, and I'll just copy this rational expression. Any other asymptotes, this will write upon the comparison of the degrees. Okay, all right, so we have a couple of vertical asymptotes, and just taking what we have in the mix. Okay, so we have for the comparison in the numerator, okay, we have n equal to 2, and the highest degree term in the denominator is x squared, so we have that m is equal to 2. And we have that n is equal to m. And from this, okay, we're going to have a horizontal asymptote. Okay, and this will come down to the constant that results from taking the ratio of the highest degree terms from the numerator and denominator. Okay, so we have with the horizontal asymptote, okay, so we have, in this case, we have y is equal to 2x squared over x squared. So we have in the end result, okay, we have that y is equal to 2. All right. Now, in what we have regarding intercepts, and we have just taking what we have now. Okay, so we have with the ratio, if we're looking for x-intercepts, okay, and again, we're looking at setting that which represents y to 0 while solving for x. Okay, so we have r of x to be the functional notation for what we have in the case of what we have for y. So we have y is equal to 2x squared plus 2 all over x squared plus 6x plus 5. And if I set y to 0, so 0 is equal to 2x squared plus 2, and we have all over x squared plus 6x plus 5. And if I just multiply both sides of the equation by x squared plus 6x plus 5, so we're going to have okay, that 0 is equal to 2x squared plus 2, okay, and trying to find out, okay, what we're going to have for the x values in this particular regard. Well, what's going to happen in this case is that with 0 equal to 2x squared plus 2, okay, if I take 2 away from both sides, so we're going to have that negative 2 is equal to 2x squared. And dividing by 2, okay, we have negative 1 is equal to x squared. Or you can say conversely that x squared is equal to negative 1. And from this, if I were to take the square root property of equality, so I would have x is equal to positive or negative I. So there is no real solution for x. And so for what this is going to signal is that we're going to have no x-intercepts. So the x-intercepts do not exist. Now, in the case of what we have with the y-intercept, okay, and in this particular case, now we're looking at solving for y as x is set to 0. So we're going to have that y is equal to r of 0. And if I set x to 0, so I have 2 times the square root of 0, which is 0, plus 2 is going to leave 2 in the numerator. And then we have all over 0 squared plus 6 times 0 plus 5. And it's going to follow that the missing y value will be at 2/5. Okay, so we're going to have that the y-intercept will be located at 0, 2/5. Okay, now I'll show you just an illustration of this particular function through Desmos. Okay, so for r of x is equal to 2x squared plus 2 all over x squared plus 6x plus 5. Okay, so for the graph I have in blue, okay, those are going to be the split up 3 regions of what we have for r of x. And for the asymptotes, now again, the graph will not come into contact with any of the vertical asymptotes. So we have, for the vertical sections, we have x equal to -5, x equal to -1. Now for horizontal asymptotes, given certain conditions, now it is possible for the graph of the function to come into contact with the horizontal asymptotes. And in the case of y is equal to 2, if you notice we have the left extreme, okay, you have the graph runs tangent to y is equal to 2. And then we have, as we get closer to the x-axis, notice that there's an intersection between the graph of the function on the far right and the horizontal asymptote y is equal to 2. But as things sort of smooth on out, just as we have had on the far left, we have to the far right. The rest of the graph is going to run tangent to the horizontal asymptote, which again we have at y is equal to 2. Okay, for number 9, now we have a rational function that is already in simplified form, and if we look for the domain, again x minus 4 cannot be 0 in value, so we're going to have the x cannot be equal to 4, and so we have, in the case of the domain, we have all values in the real number system except for 4. And we have for interval notation, you'll have those values of x less than 4, along with those values of x that will be greater than 4. And since we have the ratio to already be in simplest form, okay, the exclusion from the domain, that is going to be our vertical asymptote, which we're going to have at x is equal to 4. And in looking at what we have for the degree comparisons, okay, for r of x, again, equal to x squared plus 4x plus 9 over x minus 4. Okay, now we're going to have, again, a comparison of degrees, and there will be a difference. Okay, so we have in the numerator, highest order term, we have an x squared, and so we have the highest order term, we have an x squared, so n is equal to 2. Higher order term in the denominator, okay, it's going to be x, which is equal to 1. And so we have, in this case, right, we have that n is greater than m by 1 degree. And we have here, okay, we're going to have, well, what's going to be a slant asymptote. And the slant asymptote is going to be y is equal to the quotient as we divide x minus 4 into x squared plus 4x plus 9. Okay, and so in taking what we have now, so you have x minus 4 into x squared plus 4x plus 9. So we have x and x squared, so that will be x, and we have a distribution. We have x squared minus 4x, and taking the difference, okay, so you have x squared will go out, and we have 4x minus negative 4x, so that's going to change over to 4x plus 4x, which will be 8x, and we have plus 9. X into 8x will be 8, and distributing, we have 8x minus 32, and we're not concerned with the remainder, okay, but we have 8x will go out, and what would be the remainder in this case we will have at 41. Okay, and so, but now in terms of what we have for the slant asymptote, okay, we will have from the quotient, we had that y is equal to x plus 8. Okay, and in the case of taking what we have for the x and the y intercepts, okay, and again, r of x is a functional notation for what we say is going to be y. And if we set to 0, so we have 0 is equal to x squared plus 4x plus 9. And what's going to happen here is that once you multiply this ratio by x minus 4, okay, we're going to have that 0 is equal to x squared plus 4x plus 9. And if you were to use the quadratic formula, there will be no real solution for x and you had to signify that there will be no x-intercept. As for what we have in the case of the y-intercept, so we had that y is equal to r of 0. And what's going to happen here is if I take the same terms, x is going to be at 0, and we have r of 0 is going to be 9 over negative 4. So we're going to have for the y-intercept, location will be at 0 and negative 9/4. In Desmos, as I graph r of x equal to x squared plus 4x plus 9 over x minus 4, along with the asymptote, so we have the vertical asymptote x equal to 4, and again we have with the oblique, or in this case a slant asymptote, y is equal to x plus 8. You're going to have in the upper and lower sections, as well as the extreme left and the extreme right, you will have the sections of the graph of r of x and run tangent alongside what we have with the vertical and the slant asymptotes.